All right, so the solution methods for solving linear inequalities is no different than solving a linear equation. And you look to isolate your variable term, isolate the variable completely, and then either simplify it, rewrite it in the form that you need to. And so if we were looking to isolate our variable term here, what do we need to do to both sides first? Subtract a 3. So when you go to simplify this, the final step to completely isolate the variable is to undo this operation. To undo multiplication, we will divide. And if you guys recall, in dealing with inequalities, what's the one thing that you need to remember? If you multiply or divide by a negative, you must flip or switch the inequality. Okay, so only if you multiply or divide. So in this particular step, we divided by a negative, so what do we need to do with this inequality? Got to flip it. Okay, now, when you write your inequalities, okay, I'm going to ask you for a couple different forms of them. There's 3 forms to be familiar with. Okay, this form will be referred to as inequality form. If you're writing your answer in inequality form, what I want you to do is write the variable first. Okay, so even if you got an answer where when you solved it you had -2 is less than a, when you write your answer I want you to rearrange this so that the variable is written first. Bless you. Okay, so you would convert this answer into a compared to -2, and then you just use the direction of the inequality. So the inequality opens to the a, so when I write it this way, it still needs to open to the a. Okay, so this is the form I would want you to write it if I'm accepting an inequality form on your homework submissions or quiz submissions. Okay, the second form to look at would be the graphical form. Okay, we're probably not going to do as much with this because it's harder for you to actually sketch it out, but I want you to be familiar with it. You might see this in a problem, but the graphical form would be put it on a number line. So if you had a number line where the positive direction is to the right, you're going to plot any pieces of information that are critical values. So any numerical value that's on here, you're just going to plot that. And then you're going to sketch this on a graph. And the way that you guys have traditionally sketched this is open and closed circles. You guys kind of remember that? Okay, so would less than or equal to be an open or closed circle? It's a closed circle. So what you guys would do is you'd put a closed circle, and all your values of x that meet this condition, where x is less than or equal to -1, is that to the right or to the left of this critical value? Where it's less than is to the left. So here's probably what you guys are used to seeing, right? A dot, a filled in dot at -1, and then an arrow pointing to the left. Okay, so that is graphical form. Okay, what I want to introduce you guys to and what we'll use predominantly in this class is what's called interval notation. And this is not in the book, but I am going to expect that you be able to write your answers in this form. And what interval notation does, bless you, is it uses grouping symbols to indicate the different relationships that exist here. So when you look at this graphical form, and oftentimes it's the graphical form that gives you the best indication of what the interval notation will be. But if you look at graphical form, what is the lowest limit on your solution set? How low can we go? I know, you caught that. Thank you. All right. What's the smallest value we can get to the left here? As we keep going left, it extends all the way to infinity in the negative direction. So it extends to negative infinity. And what's the highest value that it goes to? The highest meaning furthest to the right? -1, right? So when you write interval notation, you're always going to write it as a set that exists between the lowest limit and then the highest limit. So the lowest limit was negative infinity. The highest limit was -1. We're going to separate those by a comma. And then we're going to use grouping symbols that represent the filled in dots and the open dots. Okay? A filled in dot is going to transform into a bracket, and an open dot would transform into a parentheses. Okay? So inclusion means bracket, exclusion means parentheses. So looking at this, since you can never actually reach infinity, either in the positive or negative direction, okay, you need to include a parentheses anywhere you have an infinity symbol, whether it's in the positive or negative. Thank you, Matt. Okay. At -1, are we including -1 or excluding it? Including. Okay, so if we have an inclusion, we're going to use a bracket. So this interval notation, parentheses, negative infinity, comma, -1, bracket, is the interval notation that represents x is less than or equal to -1. Okay? An easy way to remember this is if your inequality symbol has the equal sign in it, so it's less than or equal to or greater than or equal to, really what that translates to is you can kind of create the equal sign out of that bracket, right? The top and bottom horizontal lines are like an equal to. So if you have an equal to in your inequality, you'll have an equal to on your grouping symbol or on your interval notation bracketing. Okay. All right, I want to take a look at another problem and just talk through this as well. Okay, I want you to see if you can solve this really quickly. Again, not using your calculator yet. Lauren, question? Then you would put the one would be your lower limit, followed by infinity would be your upper limit. Yeah. All right, so if you're solving this inequality, what are you going to do first? Add 1 to both sides. We get -x is less than 0. And now to get x completely alone, what do we need to do? Right. Okay, so if you multiply or divide by a -1, what do we have to do to this inequality symbol? Switch it, and 0 times -1 is. Okay, so here is our inequality. Okay, if we want to sketch this really quickly, we have our number line. We plot our critical point, which is 0. And then we indicate, do we want all values that are to the right of this point or to the left? To the right. And do we want to include this point or exclude it? Exclude. There's no equal to, so we're not going to have brackets. Instead, we're going to have a parentheses. Okay, so it would be equivalent to an open circle pointing to the right. Okay, now if you think of this, you have your lower limit of 0, the furthest point to the left on your solution set. Your upper limit, this extends all the way to positive infinity. So when you write your interval notation, you're going to start with 0, comma, your highest point or highest value, infinity. Can you ever reach infinity? No, so infinity or negative infinity, always going to contain a parentheses. And is 0 included in your set? No, so a parentheses there as well. So this is what your solution would look like for this set.
What's the particular order you should put like the 0 and infinity?
It's always going to be from left to right, from the smallest value to the highest value.